In a first-of-its-kind mission, Johns Hopkins APL will send 3 small CubeSats into orbit around the Earth to study the so-called Auroral Electrojets. These are intense electrical currents flowing around the Earth's poles, central to the link between Earth and the surrounding space.
EZIE mission scientific contributions are extremely high. We're unlocking the connections between Earth and space for the first time.
We are definitely pushing the bounds of what this CubeSat can do. We have it hot, we have it cold, we have it twisting, and we have it turning.
This is part of the future direction, is multi-satellite configuration flying.
There are science questions that we have debated for 50 years, and with this technology, we can answer them.
EZIE, short for Electrojet Zeeman Imaging Explorer, is a set of 3 mini-satellites, managed and operated by the Johns Hopkins Applied Physics Laboratory in partnership with NASA's Jet Propulsion Laboratory and Blue Canyon Technologies. EZIE will provide observations that help scientists better predict interactions between the Sun and Earth. Here are 5 facts you need to know about the EZIE mission.
Earth, when you look at that famous picture from Apollo, it looks like the blue marble is just floating in vacuum. But that's not the way it is.
Invisible to our eyes is an intricate system of magnetic field lines that guide waves of charged particles from the Sun through our atmosphere. This release of energy is called space weather, which can cause dazzling auroras, but also major problems for technology on Earth.
We have transformers burning down, communication issues. There's just loads and loads of examples of how our society depends upon these conditions.
Once we understand the physics, we can improve our modeling capability, we can enhance our predictive capability of the space weather.
The satellites do not make local measurements. They're looking down.
Down at the oxygen layer below them. The Electrojets create a magnetic field around them. This field leaves a signature in light released by oxygen atoms that can be seen by the spectrometer on each CubeSat.
When the spacecraft A flies by, several minutes later, spacecraft B flies by. So we have 3 allow us to image the magnetic field or the currents on the same spot, so we can see the evolution.
We decided for this mission to collaborate with commercial space Blue Canyon Technology to take advantage of lower cost model that they have and also shorter development that commercial space provide.
Did you know you can buy a satellite online? NASA has used commercially produced CubeSats before, but typically for technology demonstrations rather than science.
We're taking CubeSats that are traditionally been used to do something simple like radio beacons, magnetometers, and we've given our spacecraft team a run for their money. Inside this box, what can we make it do and how hard can we push it for optimal instrument performance?
EZIE is a glider. The spacecrafts will carry no propellant, getting all the momentum they need for their 18-month mission from launch.
Not having that gives us a lot more room, figuratively and literally, to make decisions that are more beneficial to science and just be able to do more overall.
At 17,000 miles per hour, these objects can get around the entire Earth in just 90 minutes. Up to 600 kilometers above Earth's surface, there is a tiny bit of atmosphere. By rotating the spacecraft, we can change the atmospheric drag and adjust their speed, controlling the distance between each spacecraft. The EZIE mission is enlisting the help of citizen scientists, learners and students from around the world who will collect data alongside researchers and support the mission.
As part of this mission, we have something that is exceedingly exciting, which is the EZIE-Mag. It's a little magnetometer kit. You can make measurements, you send them to us, and you will see on this global map, hey, my magnetometer is showing up.
So the scientists are collecting magnetic field data from above, and the students will be collecting magnetic field data from the ground.
And we will use this data in the mission, so you are actively part of the team.
EZIE is paving the way for sun science missions of the future, enabling NASA to do even more exciting science to make this world a better place.